Hey everyone, my name's Jim. This is our video on the Connect 4 project. Um, this video is going to take us through a number of different presentations, different tests, all that kind of stuff. And to lead us off, Andrew's just going to take us through a demonstration of the game itself.
All right, here we go. So we start with, this is our header that we have, and we have the instructions to play. So I'll take you through a game. So we have our empty board, we'll get output, and then you type in whatever column and it'll update with your piece, and then the computer takes their turn and updates the board with their piece. So it'll keep going until you get 4 in a row. We'll see if I can get, oh, there we go. So that's illustrating the player win condition. And it'll ask if you want to play again or quit. So we'll do play again. And we'll see if we can get the computer to win. I'll try to lose this on purpose. Sometimes the computer doesn't want to win though. Oh man, okay. I just blocked him. That was oh man. Might end up winning this one. Okay, there we go. So you can see that's the output when the computer wins. And then
so column E.
Oh, yeah, you can column E straight. I wonder, I should have shown. Oh, another straight.
Yeah, that's fine. That's fine.
Then let me show you the draw condition real quick. Go to.
I think is the turn.
Is it turn? Yeah.
Yep, and then all the way up.
Thank you. All right, so we'll just change this real quick.
And then for this next game, Andrew, if you don't mind, try doing some like invalid input with like right now.
Well, right now, if I try typing in X, let's say invalid input, please try again.
Yep. And then so like if you try X right now. Yeah.
Invalid input must be cool. Allow you to keep going. So right now, this should be a draw because we're not going to be able to win.
Yep. So what if you typed in A or B right now? Just to so that's a full column, and no piece is placed when we have a full column.
Yep.
So we're getting close to the end. Yep. So
let me just.
There you go.
Yeah. Cool.
Awesome. So I think that's the game itself. We're gonna open the hood a little bit, try not to go line by line, but describe how you broke out this game. What classes did you create? What is the responsibility of each class? So we started with a board class. And so yeah, thanks, Andrew. So when it's initialized, we chose to keep track of our board with a hash. So the keys are symbols of the column headers. And then the values of each key is an array of, when it's initialized, it's an array of 6 dots. So if you scroll down a little bit, the print board, I don't need to talk too much about it. The is column full. So the way we're checking that is if it includes dots, then we know that there's still room for pieces. And then, we're checking that we're using the is column full or, is board full throughout the game. If looking at the add piece, that takes in 2 arguments, one being the column and then the piece. So depending on whether it's the human or the computer, I know that I'm passing in a specific column, and then the piece is just going to be an X or an O. So if you go to the player turn, this is a little bit of a longer method. So I'm checking if the board is full. If it's not full, then I get user input that spits out something to the machine. And then if it's where we're checking for edge cases, and then if everything looks good to go, that line 86, that's where we're adding the piece. And then the computer turn is a little bit more straightforward. We're just shuffling the valid columns and then adding a piece based on that. So that's the board class. Andrew, if you want to take us through the turn class just a little bit.
Yeah, all right, yeah. So we start with a new iteration of the board, or a new instance of the board, I should say. And you see right here, we have the takes turn method. So it starts with the player turn, first checking if the board is full. And if so, it'll be a draw condition. And then else it'll go to here and it'll check the various, check horizontal, vertical, and the two different diagonals. And then it checks if the player wins. And if they're O's in the same format, then the computer wins. And these are some of the methods we have for checking. So horizontal will take the index will be the same, but it'll step through each of the different keys and it'll throw them all into this little check array right here, which we throw into this check win condition, which checks if there's 4 in a row. And if so, it'll return either X or O if there was a winner found in that array. And then that's how it'll come back here. And that's how this will end up being true or false. Diagonal works in a kind of a different way. Starts with the letter that you want to start with, and then also the starting index for that letter. And then that's how far to step through the whole board to check all the possible diagonals. And then vertical is pretty straightforward. It just takes the column and then it checks straight down all the ones in that array. And then I think.
Yeah, no, that's good. We might be a little bit behind on time. So I'll just go through the game class real quick. Not too much for printing headers. The method play game on line 36, that's doing quite a bit of heavy lifting. That's checking to see if, the game over conditions are met and then printing out the appropriate, messages. So next kind of bullet point is their design decision that you're particularly proud of. And so they added a little Easter egg in here, but Andrew, go ahead and take us through it.
Yeah, so essentially, instead of printing out the regular board, I had it check if it's an X, it'll print out the yellow. And if it's an O, it'll print out the red. And instead of the dots, it'll just print out the black circles to act as the placeholder for the spaces. And it works the same way.
That's awesome.
Yeah.
Awesome. If you don't mind just going to the game. Yeah. So Andrew and I were talking like line 46, just we're calling a method within a method, and the argument that's getting passed in is a different method, which is get user input, and kind of arriving at that solution. We didn't know exactly where we were going when we started, but we feel pretty good about how that worked out. And I mean, yeah, Andrew, anything you would want to add on that?
Oh yeah, I think that would pretty much cover it. I like the diagonal check. I think could be refactored, but I do like how it. I think that's turn. Or is that?
Yep.
Forward? So I do kind of like it is a bit. Could be simplified, could be refactored, but I am proud of that. It actually will check every single spot on the board. It can't be a diagonal.
No, for sure.
And, the winning conditions could also be. We later thought of, we could check instead of where they place the last piece. That's all you really need to check if there's a win instead of checking the whole board.
Yeah,
but it still functions.
Yeah, no, absolutely. Awesome. I'm going to jump down to, are there any parts of your code that you're unsure or hesitant about? So posted a little bit to the instructors, I know Chris jumped on it, talked with Professor T, but there's, when we were trying to do the smart computer turn, long story short, when I added a piece to one board instance, it was also updating a different board instance. We kind of just got stuck on that. And I think, if we had designed the game differently, we probably would have been able to avoid that. And, like Andrew was talking, if we were only checking win conditions after a piece was placed on those specific columns or rows, probably could have avoided that. Real quick, tinkered a little bit with the HTTP server, the gem bundler, started on those and just didn't make too much progress. So moving on to test coverage. So if you go to the board spec.
Board spec. Yeah.
Yeah, so this test line, starting with line 40, I thought it was good. A good example of, we create a new board, it's initialized. I expect the number of dots in column A to equal 6, X is to equal 0. And then I place a piece. Now it's 5 and 1, and the specific index in that array is equal to X. And then kind of similar thing happened with 54 on. And then Andrew, if you go to the turn spec,
Yeah.
probably running out of time a little bit, but that's okay. Yeah. So like we created different scenarios for our vertical wind conditions, horizontal wind conditions, and then just keep scrolling down a little bit. Those are the diagonal wind conditions.
Yeah.
So feel good about that. Moving on, just pairing version control. So when this project got kicked off, we didn't have like a set strategy on, driver navigator, early stages. Just one person was sharing a screen, and then we were kind of spitballing off of that. But yeah, I mean.
And we had an instance of where we were working on the diagonal. We both took 2 different approaches to try to nail the best approach.
Yeah.
And yeah, I think that more or less covers the.
Yeah, no, that's good. If you got GitHub open.
Yeah.
Thanks. So early stages, we were only doing 1 pull request at a time. I would work on something, I'd push it up, create a pull request, Andrew would review it, and then we'd update our main, and just kind of the reverse of that. We had ended the project with 27 pull requests, 76 commits. Feel good about that. And then I think Andrew just has a couple examples of where, just what some of the communication around it.
Yeah, so you can see here, this is my what I wrote when I first push up the change, and then Jim would look at it, and then he'd leave his comment here.
Yep.
And then it got one over here of him leaving like a message, let me know what's going on with this change that he did, and then me commenting back, approving it. So yeah,
didn't run into too much like merge conflicts issue. There's one time where we had conflicts, and I was kind of glad that it happened just to give us some practice, but it wasn't, the changes were pretty small. So in a nutshell, that is our project. Enjoyed learning a lot about Ruby, object orientation, all that. Loved working with Andrew. It was great project, and welcome any and all feedback from y'all.
Yeah, it was definitely a great learning experience. Definitely learned a lot of different ways to think about it from other people, how they approached it, and look forward to the next project. Thank you very much.
Thank you.